But that's not simplified, right? Okay? So if we simplify this, because notice that there is no base, so what does that mean? It's common log, right? It's log base 10. So what is the log of 1,000? 3. So this would be 3 plus log of x, and so the answer should be number 2. So there's a few of you that saw that, got it right. Okay? I think this is the first time we've had a majority of people respond with the wrong answer. So you need to make sure that you read the instructions and make sure that you simplify all these down all the way that they can go. So the correct answer should be number 2. Does everybody understand why? Okay, you may not have even seen that it didn't have a base and weren't thinking about common log there. But you need to be careful with that. Okay? Okay? The next thing we have is condensing logarithmic expressions. I'm going to leave that thing there for right now. But and all this is that the rules work backwards as well. Okay? So it just means that all I did was basically switch the two sides of the equals. So it just means that if we're taking the logarithm of two separate things that are being added, as long as it's to the same base, then it's the same thing as combining the two together. Okay? I just copied that slide, so that's why that's wrong again. Taking the two things that we're taking the logarithm of and multiplying them together. But this should be the product rule here. So it's just the rule backwards. If we have the logarithm to the same base of two things that are being subtracted, then we can put them inside of one logarithm as long as we divide them. Okay, quotient rule. Okay, if we have some number down here in front of the log that's being multiplied by it, we can pull it up as a power inside of what we're taking the logarithm of, the power rule. So it's just the three rules backwards. Okay, so they just go both ways. Otherwise, there wouldn't be equal signs in them. So, okay. But it's called condensing. In your homework, it'll say expand for the first kind. In this kind, it'll say condense. So let's look at some examples of what that means. So if we needed to write that as a single logarithm, well, the first thing that should stand out is that they are to the same base, and they are being added. Therefore, we can write this as log base 4 of those two things being multiplied together inside of a single logarithm. Okay? And so that would be log base 4 of 64. Right? And I'm not sure I read my own instructions here. I'm not sure if I took that any further, did I? I did. And I don't know what, I think your homework questions will say write as a single logarithm or simplified, or in simplified form or something like that. And so this particular one would simplify further because 4 raised to what power is 64? It would be 3. Only because it comes out to a whole number. Okay, it can simplify easily. I mean, we can simplify any logarithm, but we don't want, some huge decimal number or whatever. Okay? So, quiz question number 2 here. Condense and simplify this logarithmic expression. Hopefully that stays up there. Using the same concepts there. Okay? Might have to write that down in pieces to come up with the whole thing. Okay, we're pretty close to everybody. Oh, sorry. Most of you said answer number 3. That's what you had, Cindy? What happens to numbers that are down in front of the logarithm being multiplied? they become an exponent, right? And so this 3 would become an exponent of the x right here. Does it matter that it's natural log? Does that change anything of what we're doing? No. Just like the one we had before was common log. It doesn't matter what the base is. These rules apply to any logarithm. So the 3 comes up as a power, the 5 comes up as a power, and the 6 comes up as a power. What does the addition do here? That means you multiply what you had. So we had an x cubed and a y to the 5th, so it's x cubed times y to the 5th. What does the subtraction do? Division. So the z to the 6th goes to the bottom of division, right? So it ends up being the natural log of x cubed y to the 5th over z to the 6th, doesn't it? So answer number 3 is correct. Okay. And I think that is our last slide, is it not? Yeah. Okay. So I think for the most part, this homework is going to be review for most of you that saw logs in Algebra 2. It's just reviewing all those little rules that we can do with them in terms of kind of manipulating them and simplifying them and so on. Okay? We do have, whatever, 6 minutes if you wanted to start homework. You can certainly do that. Okay? I'm going to turn on the lights, though. Yeah, once you've done all the problems, then you go back to that screen where they're all listed again, and they all have green check marks by them, to where you know you've done them all, then that's what I see. It just automatically, when you, I think there's like a save button or something at the very end. When you're on the last question, I think, there's a save button. When you hit save, it goes into a report for me to look at. And then my aide goes through there and checks to see that you did them all. It's actually a spreadsheet that tells me how many times you tried each problem, whether you completed it, you know, all those kinds of things. And so as long as you've tried them all, then you get credit for the assignment. Yep. Yep.
So basically on that last slide that you just showed us, whenever you see something in front of the natural log, you just put it in for that power?
Yes. Right.
Okay.
Right. Anything that's out in front being multiplied becomes the power inside the logarithm.
Okay. And
Yeah.
the negative was convenient for the 6 because once you put that, it became a negative because once you subtracted it, it became division, and the division you go from with like z to the negative 6th, but when you put it under it, z to the 6th.
Right. Right. Yeah. Yeah. I just remembered I do have a video for you to take a look at on our discussion yesterday that I just